Hello and welcome to another episode of Modular in a Week. This is an in-between episode between day 9 and 10, so it doesn't belong to any of those. And the reason for this is that I have moved from... I don't have the rack here anymore, or the modular there anymore. It is over here. I have put it on back in one of my movable rack shelves. And as you can see, I now have 3 rows. And this is actually what I've been doing for the last 1.5 years since I began this series. I even think there are a few modules that I haven't found that I've taken out and removed. But so I'm moving, expanding, ever expanding. And since next day will be sequencers which do take up quite a lot more space than this, I needed to do something about that. But doing this, as soon as you I've been using DuPont cables for power since the beginning, and I know many people have said that the Eurorack power bus format is the way to go, and I don't disagree. And I have a few modules that I got from a friend, or one module I got from a friend, and I think one of my modules actually has a Eurorack connector. And the power modules, the power supplies I make, they can be either Eurorack or whatever. DuPont cables, for example. So in this video, what I want to do is show how to make these power cables, because buying a cable like this is the shortest one you can buy. This almost cost as much as one of my modules, and that is crazy. And also the bus boards cost, and the power supply cost, and just the power costs a lot, and just these cables. And these are actually really easy to make, and here I have a few I've made, and you can salvage the material for most of these. So this is an old SCSI cable, IDE cables, everything uses this. And you can also buy this flat cable, flat ribbon cable, I think, something like that, on eBay or whatever, by the meter. So, and then the connectors are they're called IDC connectors, and you can also find them on eBay, or as in my case, I bought a whole bunch from LCSC, and I put all the part numbers in the description, so if you want to make your own cables, you can do that. They do not have this ribbon cable, however, but go to any thrift store or local flea market or scrapyard, and there should be tons of these still lying around. Had I thought about this a bit earlier, I would have had like a massive box of these, but I know at work we threw away hundreds of these cables just a few years ago. But that is life, I guess. So anyway, let me show you how to make these cables really simple. As for our hardware that we need to make these cables, the primary thing that I actually haven't found a good source for except to salvage them is the ribbon cable, or the flat cable. This is a cable that has been used for decades in the computer part, in all computers. So technically this you have 3 variants. You have this one that is, I believe, for floppy disks. Then you have the bit wider one that are for IDE, hard drives, and CD players. And then you have the really wide one, this one, that are for SCSI drives. All these are obsolete now, and any thrift store or junkyard or whatever should have these in piles. And if you just open up any computer that is 10 plus years old, you would probably find at least one of these. And they're quite long, usually, so you get quite long cables or loads of cables if you cut them lengthwise. And also because they're wide, we can cut them wide-wise as well. However, the only problem you get with that is that you only have the red strip on one of the cables, and then the other ones will just be gray. I've started using a permanent marker with red or white or whatever, and just marking like this. And you can also mark on the cable itself. Yeah, that's just doing it like that. So you get kind of an indication of where the red line should be, or whatever color you have. There are many colors. You don't have to use red, but for the sake of trying to keep to the standards, we do that. Then you have thinner cables. These are useful as well. So this is actually, this is a 10 stranded cable, which already has a connector on it. And this is for plus 12 volts, minus 12 volts, and ground in between. So many modules use these already, and then they in the other end have the bigger one, the 16-hold connector to add to the bus board, and then a 5 connector to connect to the module. So this one is useful as well. So just cutting this, try to make as straight cut as possible. Right here we have a very nice and very long power cable for a plus minus 12 volt power supply that doesn't need plus 5 volts. And then it's a nice little, we'll keep that for later, I guess. All these you can just cut the connectors off. You can also, if you want to, it is possible with a few different tools to actually remove these, but I'll show you, but there's holes in the cable, so you can't really use them, but they should be able to be removed anyway. I think this one we could get another centimeter just by, because in this case this was just probably something to get the pressure from the connection, so it was just folded in there. So another centimeter if we need that. And yeah, here you see how the connectors from the IDC connector cuts into the plastic. So, but with a nice, if you're really good at aiming, maybe you could aim it straight at the same holes with a new connector. Here's another one. This was a real fluke. These are really nice Nutric XLR connectors on one side, so I'm gonna salvage those. But these boards aren't useful for anything. But these are 16-pin connectors, so that is good. So I have a few cables already done here. And again, you can find loads of this stuff in thrift stores, especially IDE, floppy and SCSI things. There should be piles of that. I have hoarded the the online store of LCSC to try to find the connectors that can be used for this. Let's begin by, on the modules and on the power strip board to distribute the power, you can have these housed connectors. So this is a 10-pin connector, 2 rows by 5, usually used in many modules that only need plus minus 12 volts and ground. And they work with these smaller connectors, of course, like so. You can instead use, I'm going to link to all of these that work and all of the part numbers, so you can, if you want to, you can order there, or these ones are called IDC connectors again. These are the male ones, I guess. But you can also have dual pin headers like this. They work the same way. And this opens up for more, if you only have 16 to 16 pin connectors, then you can actually use the 16-pin connector to connect to this one, the 5-pin connector without the housing. The downside is that if you're not careful when you plug it in, you could plug it in anywhere along this line, and that could damage your module, of course. This is probably not following standard. I've used the 2x6, so 1 pin larger than the 2x5, or 2 pins, but 1 pin wider than that. And that's because that way I get all the space. Is always an issue on all boards, I guess. So on the protoboard, if I want to have 5 volts as well, I can add this one to that one, because I have another row for 5 volts as well, and that gives me, with either a connector that is 6 rows wide as well, I get 12 plus 12 volts, minus 12 volts, and plus 5 volts and ground in to the board. The 2 last rows, as I said, is just for CV and gate. So even if I use the larger one, it will just be over there, and I still have my little patch panel to patch the different voltage sources to the central bus. If you have a module where, say, a front panel, where you don't want the holes to go through, you actually have these same ones that are surface mounted. So you just place them on the board and connect them or solder them. They're quite easy to solder. It's not, when you're thinking surface mount, some people think it's very difficult. This one is very easy because it's still 2.55 millimeters between the legs, so lots of space. Just to show this and not to reveal too much of a future project, here is a front panel, and on the back side I have these 3x2 connectors that is thought to just connect like so, and that way connect it to any PCB or where the rest of the circuit will be. There's also these housed connectors that are the same way, with rows to connect them surface mount style. And I have an idea for this as well. I just bought one of these just to see how they looked and how they worked. I'll get back to that. And then of course we have the large 16-pin IDC connectors to put on the bus board or on any module where you want all the pins, plus 12 volts, minus 12 volts ground, plus 5 volts CV and gate. Then these are the connector to use. And then comes the connectors that we're gonna work with today along with these cables. So these are the IDC connectors that you put on the ribbon cable and then just put them together. So here's the 16-pin IDC connectors also so if we were to put this on this cable that has a 5x2 pin connector on one side, and we put it to that one side like so, we would have a connector that can connect to any bus board and to any module that needs plus 12 volts, minus 12 volts and ground. Together with these, at least when you buy from LCSC, you get these little extra modules that you put on like so, and you get a little handle that you can pull in instead of pulling at the cable, which is the normal way of doing it when you don't have this little handle. So let's look a bit more on just how easy it is to make these cables. So tools you'll need is a good pliers to get really nice cuts, because what you don't want is like this when the strands is out of the shielded plastic, because that will get you shorts. And you don't want that, so you want them to be really, so you can see that there is no short whatsoever along the line. This one is really frayed and really bad. You should not use this one, so you should go with a good plier and do a new cut that fixes this problem. If you have a really nice scissors, that could also work. This problematic thing here was done with a scissors that was not very good to do this with, so a pliers might be a better alternative. Now to get these on the cable, there's a few things you can do. I've used a hammer. That's the easiest thing. You just put the cable in and then you just do a few not too hard bangs on it, and that should work. If you have a we call it a poly grip, this could work if you do it in 2 passes along the, if you have the long connector, you need to do a few of these maybe. Or this is a plumber's wrench, and this could actually also work. I haven't tried it, but it seems like a good fit to just press it together. So if you have one of these, that might work as well. First of all, I would recommend that you buy one cable that from a reliable source that you know works, because when it comes to the which is which of the plus and minus and the red stripe, it is always good to look. So this is, I bought this one from thourough, so I know this one is reliable. So I know that the strip should be on that side, and then I have this as a guide for when I do this. So let's do a whole new cable here. So this is quite straight. And again, making sure that there's no shorts along the line of the cable. Here are shorts, so I need to fix that. Right. And then, because this is a wider cable than the 16 one we want, let's see, it is not exactly twice as wide, but so we'd say 1, 2. So you find the number 16. It's good to use the pliers to begin the cut, and then you can just splice it like this. So once you have it done, this one, we now have a cable with a red line, and you make sure to align it with one that works, and you put it in, and then you can, with your fingers, push it down just to make sure that it is correct. And then let's try our plumber's tool. And there we have it. And this small handle that I showed, add that. Click, click. And now we have it, a handle to pull. We can even take a piece of tape or something. I think it's meant to have a piece, not tape, but a piece of paper or something. And then you have an extra pulling handle if you want. So, also important if you've used this one, so when we turn it around, so we get it the same way around on this next one. So we take another one and like so. Let's try the poly grip, if that is what it's called. Let's say this one is not that good because it does sit, yeah. It's very shifts from side to side, so I wouldn't say that is the best way to do it. I think this one or the hammer is probably better. If there's a bit hanging out of the cable like so, you can, if you want, remove it with pliers, or if it doesn't bother you too much. Right, so there, a cable for a fraction of the price of this one. Of course, we need to check for shorts, so just putting it in a socket like this and then just going over it with a multimeter just to check so there's no shorts. And we don't need to check every pin, we just need to check the closest pins to each, of course. So that's 16 to 16. Simple one, but the special ones, so this, how many do we have left of this that we spliced? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. So this is then we can make a cable just for plus minus 12 volts, like the 5-pin ones. Now I don't think I have any 5-pin ones because they were out of stock of those. I have a few of those 2x6, so 12. That's a bit special and would not work on any module that has these 2x5, just so you know that. But you can use this again, as I said, for my proto, because I have the 5-volt connector as well. So you still need a 2x8 or a 16 pin for the one that should go in the power bus. So here you line up, again you have your reference cable, and you line it up to that side where the red line is, like so. And then you do the same thing again. Let's use a hammer this time. Let's see how well built my table is. And then you get the cable that looks like this. And this is fine. You don't need those other pins if it's not needed for that. And then you do the same on this one. We have it like so, and then over here again we need to stay on the side where we had the red line. It's the one that is important, that it is all the way out to the edge. Like that. Again, this is, so there's two left over here, and that's because this one is not. And then when you start mass producing these and you splicing these and you don't have the red line, what I like to do is take one of those permanent markers. This is a Posca. You can use any brand you want, but I know I got the tip about this one from Simon the Magpie, who uses these to draw on his guitar pedals, amongst other things. So this one is quite permanent, so you can actually draw like this, and that way, after, depending on how thorough you want to be, you can barely see that it's drawn after a while. So then we have a red line, and we know which is the red part of where the red strip should go. And as a final step, in the next episode, because that will take too long in this episode, I'll show you, so that episode will do a bunch of things. It will show you how to work in ECEDA and make a really simple design like this. This is a perfect thing to start with because it's super simple, and how to order these and get them really cheap as well. And as for the power supply, this is the same power supply that I've used before, but I did a new PCB where I beefed up the capacitors to 4,700 microfarads, so 10 times as much as before. And I also added a small circuit to add a 7805, because now I got a bus board, so now I might as well have all that. But that's for the next video. Hope you like this video and that you will get these quality cables or good cables that will maybe be a bit easier to work with and move things around, and also get commercial modules into your system sooner or later. So with that said, take care, bye.